Hello students, I am Rakesh Chauhan working as PGT Physics in Suraj group of schools. Today we are going to study about significant figures and rounding of a number. So first we are going to study about significant figures, and thereafter in the later half of this lecture or video we will be discussing about some arithmetic operations as well as rounding of the numbers. So this is the last topic of chapter 2nd, which is units and measurement. So first we will define what are significant figures or what are significant digits. So in any of the measurement we are having some certain digits and some uncertain digits which are obtained in different readings. So for example, I have taken these readings: 2.313 meter, 2.314 meter, 2.315 meter, and so on. So you can see that this first digit, second digit, and third digits are certain digits, because in any of the measurement or experiment or reading, these readings are same in any of the observation, but this last digit is going to be changed. So this digit is said to be unreliable digit or uncertain digits, while these three digits are said to be reliable digits or certain digits. So significant figures consist of all the reliable or certain digits plus first uncertain digits. So this is the definition, or this is how we write down the significant figures. So how you will define significant figures? The certain digits or reliable digits, we can say the certain digits plus first uncertain digits, uncertain digit, in fact uncertain digit in any of a reading or in any of the experimental readings is known as significant figure or significant digits. So this is the definition of significant figures. Now we are going to discuss about some rules using which we find the significant figure in a given reading or given observation. So there are several rules to find out the significant figures, which you must have study in chemistry also, but here we are going to discuss what are the various rules or what are the important rules in finding out the significant figures. So rule number first is rule first is what? That all the non-zero digits are always considered to be significant figures. All the non-zero digits in a number are always significant digits. Significant digits. We cannot put off these non-zero digits in any of the observation. So that is rule number 1. Now comes rule number 2. According to rule number 2, the zeros may be or may not be the significant figures. So now, apart from this rule number 1, all the rules are for zeros to be significant or not to be significant. Okay, so second rule says that all the zeros between two non-zero digits are always significant, no matter where the decimal point is. Significant. Okay, so this is the second rule for significant figures. Now comes the third rule, rule number 3. And according to this rule, what we are going to write down here, the zeros, and this rule is specifically made for the number which is a decimal number or which is less than 1. So for a number which is less than 1, all the zeros to the right of decimal point, but to the left of first non-zero digit are not significant. Let us try to understand it with the help of an example. Suppose I have this number which is less than 1, 0, 0, 0, 1, 2, 3, suppose. Okay, in this number these zeros are insignificant. In fact, this 0 is also insignificant, but we will discuss it later in the last rule. But here, if the number is less than 1, so is this number, then all the zeros to the right of the decimal, so this is the decimal and these are the zeros to the right of this decimal, and to the left of very first non-zero digits are insignificant or non-significant. So these 3-digit zeros are not significant so far as significant figures are concerned. So this is the third rule, which is defined only for the number if it is less than 1. Okay, now rule number 4 for the trailing zeros. So all the trailing zeros in a number without decimal point are not significant. What does it mean? Suppose I have a number 15,500. So these zeros are known as trailing zeros in the ending of a number. So these trailing zeros are not significant if the number is without decimal point. So these zeros are considered to be insignificant digit. So this is the rule number 4 for the trailing zeros. Okay, now we will write rule number 5. For the trailing zeros, it is also for the trailing zeros but with decimal. Okay, so rule number 5, I am writing here rule number 5. All the trailing zeros in a number with decimal point, not without, it is with decimal point, are significant. For example, I am taking 15.500. So in this, now these zeros which are trailing zeros becomes significant here. So this is rule number 5, which is defined for the numbers with decimal. Now let us discuss some more rules using which the significant figures can be identified. So next comes the rule number 6 for identifying the significant figures is uh, the number of significant figures do not change on changing the unit. Significant figures do not change on changing the system of units. For example, I write down here as 1 meter, and if I write down here as 100 centimeter, and 1000 millimeter, then the significant figures or number of significant figures will remain 1 in all the representation or all the units. Here the significant figure is 1, definitely. Here also the significant figure is 1, because these two zeros are trailing zeros and the number is greater than 1. So if the number is without decimal, then the trailing zeros are non-significant or insignificant. So therefore here also the significant figures are 1. And if I write this number in millimeter, then these three trailing zeros are not significant. So in all the three representation, whether it is in meter, whether it is in centimeter, or whether it is in millimeter, the the number of significant figures remain same, that is 1. So this is rule number 6, that the number of significant figures do not change as changing the system of unit. So this is rule number 6. Now comes rule number 7. Which is also like rule number 6. How this rule says that there is no relevance of powers of 10 in writing the significant figures. For example, if I write here 1 meter is equals to 1 into 10 raised to the power 2 centimeter, then also there is no role of this 10 raised power 2, because the significant figures remain 1. As well, I can write down it as 1 into 10 raised power 3 mm. Here also the significant figure is 1, since there is no role of 10 raised to the power 3 here. So in determination of significant figures, there is no role of power of 10. So this rule is basically derived from this. And now comes the rule number 8, which is in fact the last rule we can say. And this rule actually tells about that sometimes if a number is this, suppose 0.00150, so better to put this 0 conventionally before the decimal point if the number is less than 1. So this 0 is not significant, because this 0 we have conventionally put here before the decimal. So this is rule number 8. The 0 conventionally put before decimal in a number which is less than 1 is not significant. So this 0 is not significant. So these are the 8 rules to determine the significant figures. Let us try how the arithmetic calculation would change if we consider the significant figures. So now we are going to discuss that how the arithmetic operations changes if we consider or if we perform them with significant figures. So this is rule number 1, and this is for product or division. Product or division. So according to this rule, the significant figures or the significant figures in final results of product or division will be the significant figures in the individual quantities which are having the least significant figures. For example, I have 2.303 divided by suppose 1.62. So the result of this will be having how many significant figures? This is a division, but here the significant figures are 4, but here the significant figures are 3. So how many significant figures would be there in the final result? So you will say the significant figures or digits in the final result will be the least significant or equal to the number which is having the least significant figures. So out of these two number, which number is having least significant figures? So you will say 1.62 because it contains 3 significant figures. So the final result will also comprises of 3 significant figures. So whatever may be the result, but the result will have or consist of 3 significant figures. So this is about rule number 1, which is applicable for product or division. If I take product, example of product also. So suppose we want to multiply 1.414 by 0.23. So in this result or the final result will comprises of how many significant figures? So let us try first. This number consists of 1, 2, 3, 4 significant figures, while this number consists of 2 significant figures. So the result of this product will also consist of the significant figures equals to the least significant figure of individual numbers. So the least significant figures are 2 in these two numbers. Therefore the final result, whatever may be, but there will be the significant figures of only 2. So this is the rule to finding out the or to calculate or to perform the operations, or in fact product and division, using significant figures. Now comes rule number 2 for arithmetic operation, and it is for addition or subtraction. Addition or subtraction. So what does this rules actually say? According to this rule, the final result of addition or subtraction will be comprises of the same decimal places which were possessed by the individual number which is having the least number of decimal places. Okay, for example, I want to add 1.023 in 1.33. So the result will comprises of the decimal places up to which the list decimal places are there. So in which the decimal places are list, you will say in this the decimal places are up to 3, and here the decimal places are up to 2. So the final result will comprises of only 2 decimal places. So this is about addition or subtraction. So we will solve some numerical problems to understand this concept. But before that, I would like to have some rounding off rules, or how a number is going to be round off. Next, we are going to consider how to round off a number, because in calculation sometimes we need rounding off our result. So what are the various rules to round off a number? So rule number 1, which are you familiar of from your earlier classes. So rule number 1 is, if the insignificant digit to be dropped is greater than 5, then the preceding digit is raised by 1, otherwise remains unchanged. Okay, so let us have an example to illustrate it. For example, I'm taking here as 1.45 and 6. So I want to round it off. Then this uncertain digit, which is to be uh, we want to remove this or drop this insignificant digit, then this is because greater than 5, therefore how we'll round it off, we will increase this preceding digit by 1, so it will be rounded off as 1.46. so this rule you are familiar with in your earlier classes, previous classes, we can say. Okay, but what if this number which is to be dropped is less than 5, suppose 4? So you will say it will be rounded off as it is, that is 1.45. there will be no increment in this preceding digit, that will remain 1.45. so this is rule number 1. Okay, now rule number 2, which is for the number, if this digit to be dropped, or insignificant digit to be dropped, or uncertain digit to be dropped is exactly 5. If it is greater than 5, then we raise the preceding digit by 1. If it is less than 5, we will remain the preceding digit as it is. Okay, but what if this digit or uncertain digit is exactly equal to 5? So there are 2 rules for this. If this insignificant digit is 5, but this preceding digit is odd, then we will raise this preceding digit by 1, and if it is even, then this number will remain as it is, or we will drop this insignificant digit, but this preceding digit will remain as it is. For example, 1.455, I have to round it off this number, then this is 5 and the preceding digit is odd, so if preceding digit is off, then we simply increase the preceding digit by 1, so it will be 1.46. But for example, if I take 1.445, then if I round it off this number, then since this is 5 but this is even number, 4 is a even number, so there will be no increment in the preceding digit and it will become, or it will round it off as 1.44. So this is rule number second. So this is how we rounded off a number, which we will be extensively use while we are doing some calculations in physics.